I really liked the way the original Nixie lamp turned out, so I thought I'm going to actually do another one, but this time I'm going to do it for the much smaller style of lamp. So this is another of these kits that you get online, and again this one's got the clear dome, but they're available with the diffused dome as well. But it's a much smaller area inside, so I thought, how many neons can I fit in? And I decided I'm not going to be greedy this time. I'm going to make it a nice simple layout of the circuit board, so I went for 8 neons, and all pointing in from the edge just to leave maximum sort of track spacing, and that also lets you sort of point them up into a pyramid if you wish. So all the components again are in the middle of the circuit board, and were they in the middle? They were actually scattered. They were placed where they could be in the last one, but this time, you know, there's a huge void in the middle, so I've got them all nicely spaced out. And if this looks a bit arse for elbow, all the text back to front, that's because it's designed so that when it's printed out onto the, here's the transparency. When it's printed out onto the transparency and put onto the circuit board, then everything will be the right way around, and component values will be visible on the copper side just to make things easier. I've got some water in that transparency now, not to worry. I shall wipe that off, it's not really critical, but however, I have already exposed the circuit board, and this time as a treat, I put it in my proper tubes in lid ultraviolet exposure unit, which actually, you put the transparency on top, and there's a foam pad underneath, and the tubes, the ultraviolet tubes, are behind a glass layer above, and when you press it down, it really presses it hard. It lets you, firstly it lets you align it exactly where you want it in the copper, and then when you close the lid down, it presses it really hard together for the exposure time. It's also got the programmable exposure timer. So that is the copper circuit board and I've exposed it and developed it in the sodium metasilicate. So I'm about to slip this in here, and then get the bit that I've clearly forgotten, which is the, one moment please, I've left one of these through there. And this is my crude replica of the Sino GS system I've mentioned before. It's a sort of etch in a bag system, and it's just a very clean system. It also comes with a handy storage tray that holds everything, that actually supports these at the edge. It's quite good. But yes, I burst my last one as I've mentioned before, so I'm about to actually flood the ferric chloride into that circuit board. This is a heavy gauge heat sealing type material. I was actually thinking, you know, I've used the heat sealing at the ends to seal this off, but in reality I could have actually just used another of these permanently, or even a couple, just permanently pressed on to do this. It means that, you know, you can change the bag quite easily. The original Sino GS system with the ferric chloride in it that's used to etch the copper off the circuit board, it comes as a bag with the crystals, the ferric chloride crystals preloaded in it. And I'm just agitating it here. I've also warmed this, by the way, just so it's I submerged it in hot water to actually heat it up. That's another good advantage of the Sino. In fact, you know what, just give me a second. The Sino GS system comes with this plastic tray, and it supports the bag when you've got it in storage, and it also means you can actually fill this with hot water and then just place the thing in it. It's just a handy support for us, and it lets the water flow underneath. It is part of the system. It's quite handy. I'll put that back out the way. So all I did was add some very hot water into it and submerge the bag. Now, where was I? Yes, the Sino GS system comes, and I'd like to say I'm not being sponsored by Sino GS. It's just a great system. I've got, at my other workshop, I've got the full 3-tank etch system, huge big sort of, I guess they're, I'm not sure, they must be, I don't think they're not vacuum formed. They must be spin mould or something like that, rotary moulded, but they're huge big tanks, and it's got the 3 sections, the fully plumbed in and drained rinse section in the middle, and the ferric chloride and the developer section. It's designed for factories, and at my peak when I was really, you know, hammering out lots of custom circuit boards, it was very handy. But having a huge 5-litre tank system sitting there is maybe just a wee bit wasteful, when all you need for prototyping is this plastic bag system, and it keeps it super clean. It just means it's very, very clean, except when it bursts and all the stuff goes everywhere. which the CNOGS system, the only problem I ever had with it was when I foolishly ignored the instructions and stuck it in the microwave, which they actually, you know, say sort of don't do that. And, well, I did, and it screwed it up because where the liquid had been trapped with the little clips, it sort of superheated there and then it melted the plastic. So, oh well. Live and learn. That's why I ended up improvising my own. By getting this, you can buy this by the meter. It's the super heavy gauge. What size is it? Just get it. Where's a measuring tape? Or a ruler? This is what they call lay flat tubing, and it's the heavy gauge stuff. It's 6-inch, and these clips are just standard slide-on bag clips. They're all off eBay. It's quite handy. You can just buy this by, you know, the meter, so to speak, or you can buy it by the roll if you were going to do lots, but yeah, you don't really need that much. So let's see how this is etching. Initially, when the circuit board starts etching, in fact, I'll put it up to that end. Oh, there it is, in fact. Initially, when it starts etching, it goes sort of brownish, sort of red, and it doesn't look like anything's happening. But in reality, it's etching from the top down, and suddenly, you know, just when you're thinking, oh, is this even doing anything? You'll see pools of the bare circuit board material underneath the fiberglass, or in this case, the laminate I'm using is a sort of economy laminate, which is the fiberglass on the outside and then a resin bonded paper middle. I just like it because it's very easy to drill and it's that nice white colour that just lends itself to LED projects. It looks really good. So this is etching nicely. This is just going. If you use cold ferric chloride, it will take an absolute age. It really is an advantage to heat it up. Another thing about the CNOGS system, when it's reached the end of its life and you have to dispose of it, it comes with a bag of what I guess is plaster of Paris. And what you do is you open the top pouch, you pour in the plaster of Paris, close it, pull out the second strip, and then just let the plaster of Paris go in. Then you just agitate it and mush it about. And after X number of hours, it turns it into a hard mass that can supposedly be disposed of with normal rubbish. The CNO system was designed for education. It was designed for cleanliness, but it is just absolute perfect. You know, ooh, more cuts. Absolutely perfect for you know, just making up your own custom circuit boards from time to time. I think it might be a UK-based system. I certainly got mine from a company called Rapid Electronics. Now, do you see it actually etching in from the edges now? It's starting to actually pull away from the edges, which is always where it starts, and then you'll see islands appear in the middle. The way it etches, the pattern depends also on the tracks. So I'm just patting this. It helps also to agitate it. This is why many of the professional ferric chloride etching systems have air bubble agitation, but that also carries a kind of slight mist of ferric chloride out the top of the tank. As my old workshop is a testament to, the area around it is just like brown with ferric chloride. It's really messy. And it's very corrosive. It corrodes stainless steel. If you get in your single like mottlet, it just corrodes all metal, which is what it's kind of designed to do. It is an etchant. So I'll just keep agitating this here. There are two different gauges of this. I can't remember the number of this one, but it was the heaviest gauge plastic. And to heat seal this took a lot of experimentation. So in that sense, this is probably better. The first time I tried it, I thought I'd got the settings right, and I put a couple of seals and then tested the water, filled it with water, gave it a good sloosh, and the end just burst open. So yeah, maybe the clips are a much better option. They're very consistent and reliable. It means that when if you make a mess of it, if it starts wearing, leaking, you can just immediately pour the contents into another bag and get the clips on another section of the tubing. And of course, if you've got a heat sealer like I have, it means you've got some lay flat tubing to actually heat seal things in, should you wish to do so. I suppose technically speaking, you could heat seal circuitry. I'm not sure how that would go for like solar applications. So now the etching is starting to affect the other areas of copper as well. You can see it starting to cut in all over that area, and that's good. That means we're almost there. if you're getting a very slow etch, even when it looks like it's all gone, just leave it a second longer, or just a wee bit longer, because sometimes if you're in too much a hurry and it's etching very slowly, like with cold or old etchant, it can actually leave a slight haze of copper over the surface of the circuit board, so you want to avoid that completely. You want to make sure everything is off. The same happens with the developing as well. Oh, the transparency. Experimentally, I've got an old Epson S22, which is one of the lower spec printers that came free with a laptop. And just for fun, it's extremely slow, but that's an advantage. Just for fun, I took all its cartridges and I got the refillable cartridges. I'd already had the cyan, magenta, yellow and black ink in them, but I refilled them all with new ink, which claims to be ultraviolet, resistings for ultraviolet stable. And that's what I've used for this. Basically speaking, all 4 cartridges are black ink now, which took a while for the colour to just fade through. Initially it was black with a hint of yellow, cyan and magenta, but it worked its way through. And because the printer also, it means I can just print it as a colour photo, and whereas Epson tries to print, even if it's a black artwork, it tries to print it with coloured ink, so now it is all black. And also the printer is so slow that it lets the ink soak into the transparency for long enough that it's soaked in and is stable before it goes through the little pinch rollers that guide the paper out. It's got these tiny little metal cogs that just touch the paper just to guide it and keep it flat, but they can actually, on a really wet exposure, they can actually streak it. So let's see how the circuit board is doing. That is completely etched. So what I'm going to do now is I'm going to try and square that up at the end. And I'm going to squish that circuit board up and purge as much of that ferric chloride down into the lower section of the bag as possible. Don't have to get all of it, but you know what? Don't want to waste that precious ferric chloride. I'm going to get the bag clip. I'm going to slide it on to isolate the ferric chloride in the lower region, the bulk of it. Then I'm going to go through, I'm going to take the top clip off and just wash this out by just pouring water in straight from the tap. Some slight ferric chloride leakage past these clips. They're not perfect, but still not too bad. I think it's because I just didn't push it on all the way. But anyway, I'll go and do that right now. And now it's out and clean. I just put the ferric chloride back into its little storage tray here. This is the Syno-GS tray. It's just ideal for this. It keeps it. It means if this ever leaks or anything like that, you're not going to end up with ferric chloride everywhere, because, as I say, it stains everything. So it's a good storage system. So I'll just move that out the way now. And here we have the printed circuit board, just absolutely immaculately etched with all those component values printed on it. The little streak of text here is the actual text that's on the copper side that basically tells you the value of these two R resistors, because they're different for different supply voltages. So next comes drilling it and then populating it and then seeing if it actually fits in the lamp, and then we'll build a nixie lamp. Circuit board has now been cropped and drilled, or drilled and cropped. Actually I did it in the wrong order. I cropped it and then drilled it. Didn't make it that much harder, to be honest. However, it's time to put the components in. So I've marked on the back of the circuit board here, on the copper layer, 2 of the positions are marked R, and that equates to, if you look at the transparency, the resistor value for those positions will be 220k times 2 for 230 volt and 47k for 110 volt. So I'm going to be using 220k. So I'm just going to drop them in. I've preformed the leads. So that's 220Ks. I've got a 1K going in this position marked 1K. If you build this project, because I will be putting this circuit board online as well, then of course you can just play about with the component values and experiment. I mean, I'd always recommend doing that. A diode, and then afterwards I'll be putting in a capacitor. Now I'm not using the ceramic capacitor because that was quite noisy last time, the ceramic. I'm using I think this is a small Mylar film capacitor, much quieter. So I'm going to put these components on the copper side as opposed to the other side, simply because I want to leave the front side completely clear. So let's start soldering that now. The diode can go around anyway, to be honest. But I've just marked a position just in case of doubt. It's a very easy circuit board to make, this one. It's only got 8 neons on it, so it's just that little bit easier than the other one, which was quite complex in terms of same components on the back, but the number of neons just made it a bit trickier. I'll also put some solder onto the neutral pad and the live pad where the connections are the mains connections are going to go onto. Okay, so that's those components mounted. I shall crop the leads now while I'm at this. Let's find my precious new Xuron snips for this, since they do such a good job. Just cut them nice and flush with the front of the circuit board. I'm going to have the neons either sitting on that, or I may actually lift them up a wee bit. I'm not 100% sure yet, because I'll just make it up as I go along, like I normally do. So I'm going to sit the capacitor across like that momentarily, but I'll straighten it out afterwards. If necessary, it might not be necessary, so I'm just going to hold that like this. And people often mention about my multi-fingered soldering technique. To be honest, I didn't even know I was doing it. It's just something that's evolved over time, just because it's convenient for me to actually do it this way. Soldering is one of these things that, you know, it's an easy enough skill to learn, but, you know, as time goes on, you sort of pick up different techniques. Right, so that's all the circuitry on, and that just leaves the neons. So I'm going to stick probably about 4 on initially, and then solder them, and then the other 4. I'm not sure how much room there's going to be here. So I shall start populating the front with the neons. Could have trimmed these leads down a bit. Might have been a good idea to trim them down a bit. I'm not super bothered about them 100% lining up in the front. They're going to crisscross a little bit. There's enough play in the leads to actually squish them about a bit afterwards. So for this, I'm actually going to place it down on the table to actually solder these ones. And I'll probably just solder one lead at a time, and then just check it's everything's sitting square in the front of the circuit board. This is when a little something to hold. It would have been quite handy, but it doesn't really matter. Okay, that's one lead soldered. How are they looking? They're looking just fine, to be honest. Yeah, that's absolutely perfect. Okay. Now they're held in, I can hold it in my preferred manner. Yeah, this is very easy to assemble, this circuit board. It really doesn't take much time at all. It's a cinch. And that just leaves 4 more neons to go on. I did notice this circuit board that was supplied with this LED lamp kit is really thin. I measured it and it's 0.8mm, whereas this is 1.6mm, and it has little spacers in here that may just be to lift it up to let air ventilate underneath, but it's not needed in this light because it's not going to dissipate that much power. So I may have to Dremel off, just grind down these little spacers. I'm not sure yet until I actually try putting the lid on. The lid may fit, otherwise, if it doesn't fit, it may actually just keep popping off, which wouldn't be very good, because then I'd have a live circuit board dangling out, which is never a good result. Always very stylish, live circuit boards dangling out of things, but not necessarily a good result. There's something strangely futuristic about dead electronic equipment with all the wires hanging out it. And I have to say, I've seen quite a few compact fluorescent lamps that have been hanging open. Oh, this is going to get quite tight in here, actually. Yeah, I'm going to have to stack these neons up a little bit, I think. That's just greed, me trying to cram as many in as possible, but I thought 8 was a reasonable number, but obviously I've been unreasonable again. Rightio. This time I may try and... yeah, I'll try and hold them in with one finger in the middle. and just solder one connection again. Long leads getting in the way here. I think I'll reflow that joint afterwards. In fact, I'll reflow that one now. It's just a wee bit messy. Oop, knocking tools off the bench here. That's one of my little screwdrivers. How's that looking? That's looking all clustered. It's a cluster of neons. I was going to say a clusterfuck of neons, but yeah. Actually, you know what it is? That's might be what I call it. I know I annoyed some people by calling the last one the nixie lamp, and the reason I called it the nixie lamp is because it's a sort of active neon lamp. The purists prefer that nixie should only refer to the original branded nixie tubes. Okay, that's looking pretty good. It's already looking a bit 3D in the front, but I'm wondering if I should space them up, if I should actually tilt them up a little bit. It's looking okay. I might just prise these ones up just a wee tad, just to give it extra dimensional appearance. In fact, I might just pop the other ones up as well. Yeah, that's quite nice actually. It gives it a very 3D look, which is good. Oh yeah, that's quite nice actually. It's a little dome of neons now. Right, so let's now solder the mains leads on, which are tucked in here. I'll just flow these with a bit more lead-based solder, since it sticks better. For all I know, these are already covered in lead-based solder. You just never really know what you're getting from different suppliers. So I'm going to flow that one onto neutral. Actually, technically speaking, if I was doing it properly, that would have actually gone on to live, since it's the back connection. It doesn't really matter though. Yeah, actually I will. Because then it's the middle connection in the lamp holder is theoretically live. It's the hot one, if you will. So I'm going to put it to the live connection I've marked on the circuit board, because it's got the two resistors straight away, which kind of like limits the current. It doesn't really matter because I'm going to be using it in a bayonet cap to Edison screw adapter, which completely defeats that whole polarity thing anyway. So let's get the other connection onto the neutral here, which is the ring of the lamp base, and that's the job done. Now all I have to do is just sit this down into the housing like this, and I wonder if the cap is going to fit on. I don't think it is, because I think it's just that wee bit tight. It's a tight cap anyway, because all these caps seem to be really tight, but I don't know if it's going to be stopped from clicking into its support by the circuit board. Blimey, it's not even clipping down. That is a very tight cap. I might actually even have to heat the plastic to make it just pop in. Or use just brute force. Maybe I'll just keep using brute force until it bursts. Oh, that is just very irritating. I don't think this is going to want to go down with that slightly thicker circuit board. I may have to make the adjustment to its thickness. But let's keep faffing around with it anyway and try not to mash the neon lamps in the process. The other one was really, it was just absolutely horrific to try and latch in, and this one is no different. Right, okay, you know what? It's not really wanting to stay down. I'm going to have to Dremel out those wee spacers. Right, I'll be back in a moment. So this is what it looks like when it's first running. Initially, before it's really settled in, you'll just get one or two neons hogging it, and it will gradually, as over time, it will start more and more will start kicking until they're all doing it. However, a couple of things worth noting. I tried the Dremel to remove those little studs that keep the spacers that hold the circuit board up, and to be honest, a pair of fine snips was much better at just nibbling the plastic away, because they're quite easy to clear off. Secondly, I fucked up. I screwed up, and by the time I'm going to put this circuit board file on the internet before I release this project, and it will be corrected by then, but there is a slight design fault. Something along the lines of both sides of the neons being connected together by a 1K resistor because one track was in the wrong place, but that's okay. It will be corrected. This is, after all, just a prototype. So I'll let this settle in a bit and then show you what it looks like once it's actually kicking into action. But so far, it looks quite... I like the glass under the plastic. I think that's, you know, just like the other lamp. But this one is quite stylish because it is just a nice simple dome. So I'll be back shortly to show you what it looks like once it's settled in. And the rest of the video will be it just doing its thing, because it took about 2 days to fully settle in and get into the swing of things, but now it's done that. It's just churning away and doing what it's supposed to do. It's strange and completely random shimming about of light. I do like the sort of pyramid of the neons inside. If anything, they could be stood up a wee bit higher. It's quite a nice little circuit board, that. Easy to build, and it's quite an attractive effect. You know, I should actually just doodle that circuit schematic out for you, so I'll do that right now. So a quick recap on the circuit, it's super simple. It's just two current limiting resistors. In the case of 230 volt, which it really covers anything 200 to 250 volt, you can use two 220k resistors in series. For 110 volt, I'd suggest playing around with values, but 2 times 47k should be a good start. Then there's a single 1 amp rectification diode. It's not even remotely fractionally near an amp, and this one's a 1000 volt diode. It's not even fractionally near 1000 volts. A 400 volt diode would probably find anything more than just a milliamp, basically. But the 1N4007 diode is a super standard diode. A capacitor, 10 nanofarad, 100 volt. It only needs to be 100 volts because as soon as the voltage exceeds about 90 volts, the neons will start conducting and discharge capacitor, so it's never going to get up to 100 volts. The type of capacitor, if you use a ceramic, it will potentially, the little disc ceramic capacitors do make that really annoying noise because of the sudden discharging, and it makes them basically buzz with quite a notable sort of high frequency noise. So I tend to use sort of mylar film capacitors, which is just something that came to hand. It's just any sort of generic 10 nanofarad 100 volt capacitor. Then there's a 1K resistor. All these resistors are quarter watt, and its job is to limit the peak current when the neon strikes and the voltage goes from about 90 volts strike voltage down to about 50 volts, and suddenly you get a 40 volt difference change, and that results in a high pulse of current going from the capacitor through the neons. And without this 1K resistor, and I can recall the experimentation I experimented, it had to be as low as possible for the best results. But if there was no resistor there, the neons would visibly start to sputter. They'd darken over time. With it there, that prevents that happening, or at least certainly restricts it happening over a long period of time. And really after that it's just a parallel array of as many neons as you want. However, they have to be matched, you know, they all have to be from the same bag, so to speak, just to make sure they've all got the same forward voltage. If you don't do that, if there's a significant difference in the strike voltage, then the one with the lowest strike voltage will just hog all the current. It just won't ever really jitter about the other ones. But if you do get a pretty good mixed bag of matched neons, that's if you get a bag of matched neons, would be a better description, then they should all have a fairly similar voltage, and when you power it up, it may take a few days, and it'll be most active at night time, but it may take a few days to just settle in and balance the voltages, but then you'll find that they really jitter about randomly. So super simple circuit, really quite fun to build.